morning everyone. In this class we have the topic energy and its forms. This is from ICSE class 10 physics. As we have already studied about work, and we all know that a force, an application of force must be required for the work done. That means there is a need of a source which can exert a force. Without this force, there is no any work done. So the source is able to, there is a source which is able to apply force. So what is inside the source? See, this is, suppose we have the source, this is body 1 as the source, this is applying a force F on this object for the work. So what physical property, what physical quality does the source have? What is inside the source because of which it is capable to applying a force F here? So this physical property, this physical quality is called the energy. That means this source has some energy in it. Because of this energy, it is capable of applying a force F here. This is the energy that the source has. Now come to the work done. If the force is applied on this object, then what do you say? Is there any work done? See, work is equal to force into displacement. That means even if there is a force applied and if there is no any displacement, there is no any work done. But however, this source is able to apply a force F on this body which fulfill the first condition for work done. That means the body, this source have some energy in it. Now, when there is a displacement, then what we say? There is a work done. So if force with the displacement, then work done equal to force into displacement. So by the application of this force, the body too displaces. There is some displacement. Then we say that there is some transfer of energy from this source to this object. From body 1 to body 2, there is some transfer of energy, and when there is a transfer of energy, then we say that there is some work done on this body by the body 1, that is the work done on the object by the source. If there is a source, if there is a transfer of energy from this source to this object. Without this transfer of energy, there is no any displacement, and if there is no any displacement, then there is no any work done, even if force is applied. See this, force is applied but displacement is 0, then there is no any work done. Work equal to force into 0 to 0, and no transfer of energy. If there is no any work done, there is no any transfer of energy. When the displacement is 0, there is no transfer of energy there. So, if there is a transfer of energy, then what we say, this source lose or decrease some energy, and this object gain or increases its energy. So what we found, that work done by an object loss or decreases its energy, and work done on the objects gain or increase their energy. See, we have the definition of energy. The capacity of doing work is called energy. During the work there is transfer of energy. So as there is a transfer of energy, this transfer of energy, the amount of the quantity of the energy that transfer is actually same as the amount of work done. That means the energy and work are exactly similar to one another. When there is a transfer of energy, this quantity of energy is equal to the amount of work done. As the amount of energy transfer is equal to amount of work done, so as the work done is a scalar quantity, so this energy is also a scalar quantity. So energy is a scalar quantity. Now what is the unit? The unit of energy is similar to unit of work. That is we have the SI unit of energy as joule. CGS unit of energy is similar to CGS unit of work, that is R. Now we have some commercial unit of energy, that is kilowatt hour. So this kilowatt, watt means the unit of power, and you all know that power equal to work done by time. Work done may be taken as energy by time. So this energy P becomes C P into T, power into time. So now this unit, which is actually the unit of energy. See, we have kilowatt, which is the unit of power, and this time is time as a unit hour. So this power into time gives the unit of energy. Now how to relate the SI unit of energy to this kilowatt hour? See, we have 1 kilowatt hour. So here we can easily convert, like 1 kilo means 1000 watt is watt W, and this H means 3600 second. Now we have 3.6 into 10 to the power 6 watt second, and you all know that watt second means watt second, power into time. Watt into second gives the SI unit of energy, that is joule. So this one, that is 1 kilowatt hour, is equal to 3.6 into 10 to the power 6 joule. This is what we have. See some other units. Calorie. Calorie is one of the unit of energy. 1 calorie is equal to 4.18 joule, and one more unit, that is electron volt, EV. Electron volt is also a unit of energy. Now what is 1 electron volt? 1 E, that is 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb, and this coulomb volt become joule. So this one become 1.6 into 10 to the power minus 19 joule. So 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. So these are the units of energy. See, mechanical energy is a form of energy, and this energy is the energy possessed by a body due to its state of motion or state of rest. Rest under a force. We can understand this by taking some example. Suppose we consider here a spring fixed on a wall. Now we apply a force by our hand on the spring to compress it. See, the slinkies of the spring get closer after pressing it. So this point of spring displaced to this point. So there is a displacement. See, there is a displacement. So force with the displacement, that means there is some work done. Who did the work? This hand did the work. So this hand act as a source of energy here, and you all know that when a source did some work on any object, then it transfers some energy. So this source transfers some energy to this object, that is the spring. So as there is a transfer of energy, this spring gains some energy, and this gained energy of this spring is stored in this spring, up to which it is retain its rest position under a force. So up to which it is at the rest, in the state of rest under a force, then it has stored the gained energy here. If we release the force, then this stored energy can be utilized. See, if we release the force and if we put a ball here, then this spring comes this way and push the ball toward this. So now as the force which takes this one at rest state is released, so this springs come this way and push the ball. So this spring, which stores some energy, has the ability, that means it is capable of applying force on the ball. So this means that this spring has some energy in it whenever it is at rest position. See, this energy is called potential energy and represented as U. One thing we should notice here, when we apply a force on the spring, the direction of force is against the wall. See, this one gives the direction of force. Now, as the hand did some work on the spring, and there is a transfer of energy, and this spring gains some energy as potential energy. To utilize the potential energy the spring has, we release the force that maintain the rest position of the spring. whenever we release the force, the spring is capable of applying a force toward this direction. See, this is the direction of force that the spring can apply, and this one is the previous direction of force. Those are opposite in direction. See, force is applied in this direction initially. Now the spring can apply a force opposite to the previous direction of force. So this energy that the spring has is now negative potential energy, because it can apply a force opposite to the previous applied direction of force. So it is the negative potential energy the spring has. Now here we are considering a moving object. Suppose we have a ball which is in motion. This moving ball can strike a ball 2. This one is ball 1, this one is ball 2. And now this moving ball is capable, we can say this moving ball is capable of exerting a force on any other ball. That means it is capable of doing work. That means what? It has some energy in it because of its motion. If you see here, the ball is at rest, and anyhow the ball 2 is in contact with the ball 1. But the ball 1 is at rest, so there is no any application of force by the ball 1 to the ball 2. So that means what? This ball 1 has zero energy, no any energy, as it is not in motion, as it is in the state of rest. So as here an object, the energy possessed by an object is caused due to its motion. An object is capable of doing work because of its motion. So this kind of energy is called kinetic energy, and this kinetic energy is represented as K here. This one is kinetic energy, and this one is represented as capital K. See, the potential energy is of the type gravitational potential energy, elastic potential energy. Some other potential energy are also there, magnetic and electrostatic potential energy. So magnetic potential energy and electrostatic potential energy means when suppose two poles of a magnet are separated by a distance, then those poles have potential energy in them. Suppose two charges are separated by a distance, then those charges also have the electrostatic potential energy. Now we will study about the gravitational potential energy. Let's see. We have studied about the work done against the gravity. This is suppose the surface of the earth, and this object is lifted upward by applying a force mg. Mg is the load, so mg is the force applied on the object to lift it up to the height h. So work is done on this object. Now the work done on the object is equal to, as you all know, mg into h. H is the displacement here from this point to this point, and mg is the force here, and h is the displacement. Force into displacement is the work done. As you all know, whenever work done on an object, work is done on an object. Suppose here we have this object and work done on this object, so there is a transfer of energy. That means this object gains some energy. This energy is stored as potential, the gravitational potential energy in this object at this height, because this is the height from the surface. Now to maintain its gravitational potential energy constant, we have to maintain the object at certain height. So there is always a force which maintains its rest position at that height, and because of this the object has the constant potential energy at the height. Now whenever this force is released, the object starts to fall down. Then as it falls down, the height decreases and its potential energy is also decreases. Here we also notice that initially for work done, the force is applied vertically upward, and now whatever the gravitational potential energy the object has, by this potential energy it can exert a force, but now whatever the force it can apply or exert is vertically downward, which is opposite to the previous applied force. So that means it has the gravitational potential energy, but this potential energy is considered as negative potential energy, as initially the force is applied for the work done is opposite to the direction of the force that it can apply. So here U is the potential energy, mg, h, and it is negative potential energy. we do not mention here the negative sign. Why? This is simple because energy and work done is the scalar quantity. So this one is negative potential energy. Here we have taken an object of mass m at two different heights h1 and h2 at the point A and B respectively. As you know that the object at the point A has the potential energy UA is equal to mg, h1 is the height, mg is the force, and here at the point B it has the potential energy mg, h2. Now if we suppose that the object is rises from A to B, from point A to B. So what is the work done? So here the work done is equal to work done AB is equal to mg, which is the force that is to be applied on the body, and what is the height here? See, this one is h dash. So here h dash is the height. Now, as you all know that this h dash is equal to h2 minus h1. Now we have mg h2 minus mg h1. So what you found here? This work done from A to B is equal to UB minus UA. So the work done in bringing the object from A to B against the gravitational force is equal to the difference in their gravitational potential energy at those two respective points B and A. So if we consider here that when the object is lifted from A to B, then some work is done on the object. So that means this increases the energy of the object. That means the object gains some energy when some work is done on the object. So UP, that means when the object reaches to the point B, it has initially the energy UA and it is added with the work done on the object A. Now suppose the different condition, opposite condition, if we consider that the object falls down from B to A, then there is some work done by the object. That means the object itself did the work. When the object falls down from B to A, then the work done is equal to, again you can write here mg. Now mg is opposite in direction as A to B. We have taken mg upward, now the mg is downward. So here again the height is same, that is h dash. Now you can write here again the same way mg h dash as h2 minus h1, this one is h dash. So h2 minus h1. So finally you get here WBA is also equal to UB minus UA. So that means when the object falls down from a point, then whatever the work done by the object is equal to the difference in their potential energy at those two respective points. See, here we have work done by the object WBA is equal to UB by UA. So when the object itself did some work, then what happened? It loses some potential energy. So now at the point, after reaching the point A, it has the potential energy UA and some work is done, UB, initially it is at UB and it falls down to the point A. So after it did some work, so this work done is subtracted B to A. Now we will know about elastic potential energy. As we have taken the example of the spring, when external force is applied on the spring is compressed. We have taken the rubber band, when force is applied to pull the rubber band, it stresses the rubber band. So this stressed rubber band and this compressed spring have potential energy in them. This is only because those objects have the property to regain their original shape or original size. Every object has the property. So the property of an object by which they regain their original shape or original size is called elasticity. And this potential energy that those have is called elastic potential energy. This elastic potential energy is the energy possessed by an object due to its change in shape or change in size. However, the objects can hold this potential, this elastic potential energy, as long as they maintain their deformed state or change shape. If they regain their original shape, when they are starting to regain their original shape, then their potential energy, elastic potential energy, start to decreases. Let's see how. See this, when it is regaining its original shape, U decreases, and when it's got its original shape, then U become 0. So this potential energy that the object has is actually, this U elastic potential energy is actually work done. It is equal to work done on the object. See, here we have applied a force, so some work is done on the object. So this work done, this amount of work done is equal to the potential energy, the elastic potential energy stored in this object.